Hi, everybody.
Yep.
Welcome. So my name is HuxleyBarbee. That is actually my real name. It's not a handle. And I'm the only HuxleyBarbee you're ever going to meet. Let's go to the next slide, please. Next slide. There you go. OK, cool. All right, so this is a little bit about me. I am the organizer for B-Sides New York City, and I love going to other B-Sides to check them out. This is not my first time in Calgary. I've transited through Calgary in the past. I actually had a project in a town called Medicine Hat, which was my first introduction to Alberta. I'm also the security evangelist at Run Zero. If you're afraid of QR codes, that's the link if you want to connect with me. But more importantly, I've had an extended career as a security consultant, and many of my customers have had OT environments that they had to protect. So we're talking about, for example, all the signs that you would find in a rail station or a bus station, or a manufacturing plant and all the manufacturing devices that they may have. And even some cases, higher education, they have OT devices as well. And I don't have my slides, so I don't always know what's coming next. All right. So in this talk, I hope that, one, you'll learn more about OT and ICS than you did an hour before. And you'll learn about some of the challenges around protecting OT, and also challenges around figuring out what you have in your OT environment and some of the ways that you can deal with those challenges. So before we go to the next slide, can anybody tell me, of all the chips that are manufactured, what percentage of them go into embedded devices, or non-IT devices, I should say? Wager guess. 98? 90, no. 91? Let's do Price is Right. So I want you to go as close as possible without going over. You went over. 99 went over. You're right on. You are right on, yes. Next slide, please. Approximately 90% of chips that are manufactured are meant for the devices that are on the right-hand side over here. So if you can imagine, the attack surface for the adversary is actually much larger on the right-hand side of this diagram as opposed to the left-hand side. In this talk, I'm going to be focusing on this group over here, the OT devices, right? And what do I mean by that? Because oftentimes there's a lot of this conflation of IoT and OT, so I want to take a moment to explain the difference. With IoT devices, we're talking about headless devices that tend to be in your office or your homes. They tend to not be considered critical infrastructure or key resources. Whereas the devices on the right-hand side here, what I'm calling OT, are sometimes, there's a subgroup of them called ICS, Industrial Control Systems. These are critical infrastructure. These are dams. These are transportation, manufacturing, all sorts of environments where they're doing things that have some sort of ramification for our society and our lives. Another way I think about OT versus IoT is, if I walk into that environment, do I need to wear a hard hat? Right? Which is not 100% true, but it just gives you some sense of, okay, these are the types of devices that matter to our lives, our society, that make our cities and our states function, our provinces function as well. One thing I want to note here is, oftentimes, medical devices are considered Internet of Medical Things. However, because they are critical infrastructure, I include them in OT as well. Okay. Yes. Outside. Okay. Sorry, everybody. All right, so if you are like me, you probably grew up on the IT side, right? Because in your dorm, you could set up a server in your laptop or what have you, and you could go play around with stuff. Very few of us have had a chance to have a robotic arm or an intelligent conveyor belt in our dorm rooms. So OT is a little bit foreign for us, right? So I want to take a moment to go through and explain what an OT environment looks like so you have a better baseline understanding. All right, so let's go to the next slide. Actually, let's go to one more. Okay. So a big caveat here. There's a lot of variety in OT environments, right? They have a lot of, because they have a lot of specific devices. I don't know either. So if you think about the IT side, we have our pieces that we have our Macs. They can be used for many purposes, right? Financial modeling. On the OT side, devices are very specific for their one task. And because there's so many different tasks, there's a lot of variety because they're all built specifically to do that one thing. And so I'm showing you an example here, but just realize in the real world, there's a lot of divergence from this particular example. Okay? One example, lots of variety. So what we have here is a water treatment facility, right? So there's this tank here. There's dirty water that comes up from the left pipe here, goes into the treatment tank, right? So this valve opens up, and this pump has to pump the dirty water in, and it sits in there for about an hour before it comes out. Right? The way this operates is when the water is lower than the lower sensor, that's a sensor, lower than the lower sensor, the pump starts pumping water in, and then after an hour, after the water reaches the higher sensor, then the pump stops, and it sits there for an hour, and then gets drained out. Let's go to the next slide, please. So these two things here are sensors, okay? Let's go to the next slide. Whereas the pumps and the valves are known as actuators, right? And collectively, these are field devices oftentimes. And in the real world, you actually might see the sensors and these actuators combined into a single device, in an integrated field device, for example. Next slide, please. Smarts, usually. There are no smarts on those field devices. All the smarts is in that PLC. Next slide, please. Typically, a technician or an operator doesn't touch the PLC directly. Rather, they operate through an HMI. When I say HMI, you should think of, like, let's say, house. Pushing some buttons or flipping some switches. Next slide, please. That particular PLC is done through an engineer's workstation. And typically, this actually is an IT device. And typically, it's running some really old version of Windows. XP is not unheard of. I have actually met somebody who said he once found Windows 3.1 on an engineer's workstation. All right, let's go to the next slide. Okay. So what you see in this one circle here is what is known as a system. And when you have a site, you might have multiple of these systems collaborating together in what is known as a distributed control system, DCS. But there are cases where you would have each of these little systems distributed out over a large geographic area and organized into what is known as a supervisory control and data access, a SCADA. And in those cases, you would have a remote, an RTU over here, that brokers the conversation between the PLC and some sort of central location, mission control, if you will. All right, so that is OT. This is an OT environment. Again, it's one example. In reality, there might be a lot of variety. But hopefully, it gets your mind thinking in the right way about what type of devices we're talking about here. Next, I'm going to move on to what are the challenges in securing OT that's different from IT. Let's go to the next slide, please. All right, so in IT, we tend to be focused on data, making sure only certain people can get to that data. Is that data encrypted, at rest, or in motion? And so on and so forth. Is that data backed up, and so on and so forth, right? On the OT side, we are very much focused on the movement of machinery, widgets, and gears, and so on and so forth. Next slide, please. Typically, IT devices don't live very long. How many have a phone that's on the OT side, these devices tend to be in operation day after day, second after second, for decades. I even heard of some locations where the time horizon for these devices goes on for about 50 years, right? So really, really old things. Let's go to the next slide, please. All right, so one thing that's different about this talk is I'm giving away money. So who can answer this question for $5? So that hand went up first. That is correct. The CIA triad. Next slide, please. On the IT side, I think all of you know this, right? We're very much focused on the three different pillars or three different concerns, I should say, of the CIA triad. On the OT side, it is not the same. Availability is relatively way, 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 way more important than confidentiality and integrity. And I want to dig into a little bit why that is. So when an IT system goes down, people can't log in or whatever, like, the transaction doesn't happen right away. When an OT system goes down, that means the factory's not building things. That means the oil is not flowing through the pipeline. That means the water is not flowing out to the municipality, right? Depending on type of organization, you can sort of understand why availability is so important, right? If you have a commercial organization, every second that OT device is not operating like it's supposed to, one, that's revenue lost, but two, these environments are considered critical infrastructure. And so they are heavily regulated, and when they go down, the government is going to come in and start inspecting and potentially fine that organization for that outage. So in the United States, Colonial Pipeline went down, and FINRA, which is the regulatory organization for oil and gas, came in and fined Colonial Pipeline for $1 million. So it's not just a revenue loss, but additional fines. Now, if we're talking about not a commercial organization, but a quasi-governmental organization, you can imagine there's some politician out there who really does not want the bad press of the recycling plant not operating properly, or not having clean water for the city. So for a variety of reasons, there's this really, really strong focus on availability, far, 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 far less on confidentiality and integrity. All right, next slide, please. On the IT side, we have these operating systems that we all know. But on the OT side, we don't have time-sharing operating systems. We have real-time operating systems. And further, there are way, way, way more of them. And so think about what that ramification would be. Let's say you are a vendor that's building an EDR, selling an EDR to the world. What would you do? Well, you would build an EDR that's compatible with Linux and then OS X and then Windows, and probably not bother with BSD, unfortunately. But what does that mean on the OT side? Are you going to build out 65 different versions of your EDR? Especially when those operating systems are proprietary, so you can't even get a copy of that operating system to try to build against it. This will be important later, so keep that in mind. All right, next slide. Programming languages. You all know the programming languages on the IT side. On the OT side, they have completely different programming languages. And so what this means is the last many decades of innovation in software engineering, release engineering, quality assurance testing, SDLC, and so on and so forth, they do not carry over to the OT side. This, by the way, is sort of like an IDE for one of these programming languages. All right, next slide. All right, so on the IT side, we have Microsoft Patch Tuesday, right? We're all familiar with that. On the OT side, it's either Patch Never or Patch September sometimes, yeah? Why is that? Well, this goes back to what I was saying earlier about availability. These organizations do not want to take any downtime whatsoever to run a patch, to run an update, and they absolutely want to avoid any sort of extended downtime that might occur from a bad update. And so for that reason, most organizations do not patch, or they rarely patch. All right, next slide, please. All right, you might think I'm funny for saying that IT is secure by design, and arguably you're right. But on the OT side, It is way more true. It is insecure by design. I'm talking about devices that don't require authentication, devices that do not encrypt their traffic, and so on and so forth. Next slide, please. On the IT side, typically there's some sort of governance, right? Everybody needs to have EDR on their device and so on and so forth. On the OT side, depending on the industry, there might be nothing. There may be no security controls. And in fact, typically there's also no governance, meaning devices are left online with default usernames, default passwords, with default configurations like listening on default ports and so on and so forth. All right, next slide. On the IT side, devices are directly or indirectly connected to the internet usually, right? But on the OT side, this is where things are different. Back in the day, if you wanted to compromise an OT device, you actually had to walk up to it. And then starting around 2005 or so, that started to change. So it changed because of the business. On the operational side, in order to gain efficiencies, they wanted to connect all these OT networks onto the IT networks. Think about it this way. Let's say I have this pipe out in the middle of nowhere, and somebody has to go flip a switch. If we're air-gapped, that means I got to fly this person, this technician, out to the middle of nowhere just so they could do this one thing. One, that takes time, and two, that costs extra money. Wouldn't it be nice? Wouldn't it be so much better for operational reasons if you could just remotely make that adjustment on that particular device? And yes, absolutely. Operationally, that would be way more efficient and way more cost-effective. But what this also means is that that curtain of being air-gapped came down. And frankly, in my opinion, it is because these environments were air-gapped that people were okay with not having patches, that people were okay with not having security controls, that people were okay with having default usernames and passwords and so on and so forth. But once that air-gappedness came down, all of a sudden, all these insecurities of our OT environments were laid bare to the adversary over the internet. All right, next slide. Who can tell me what's the name of this model? Oh, there you go. He was fast, sorry. All right. Yeah. So some of you might say, based on my characterization of OT, no, what are you talking about, right? There's this thing called the Purdue model. All right, so let me explain what Purdue is, right? So, next slide, please. What we have here is a stratification of an OT environment where you are separating your levels of risk into these layers. And what's supposed to happen here, before I say what's supposed to happen, so down here you can see the field devices, right? The sensors, the actuators, you got your PLCs over here, the HMIs over here, and so on and so forth. And then way up there, there's more IT stuff. So what's supposed to happen here is devices in each layer is not supposed to communicate beyond the adjacent layer. So if I'm in layer 1, I can talk to 0 and 2. I cannot talk to 3, 4, 5. The other thing that's supposed to happen is in between these layers, you're supposed to have some sort of security control, maybe an IPS or a firewall that's adjudicating the communication among those layers. So a couple of things here. Two things that I want to mention for the people who are Purdue fans, right? First and foremost, you can see at the top there, that's more IT-ish, right? Those are IT devices, whereas down here it's super OT type of device. Based on what I've told you so far about the lack of security controls and lack of governance, what's going to happen here is the moment somebody can infiltrate the top, each layer down gets easier and easier. Each layer gets easier and easier. So if you can get in through the top, it's a foregone conclusion that they're going to get to the bottom. It's just a matter of time. And number two, very, very few, if any, organizations fully express Purdue. It just doesn't happen. It's a very nice model, but that's all it is. It's not actually done. can we go 2 slides, please? So remember, one more. Remember what we said earlier, the PLCs, they're supposed to be down there, like layer 1, right? So you should be going through like 5 other layers before you can get to it. Fact of the matter is, you can use Showdown, or even just Google to find a PLC that's directly connected to the internet. What happened to layers 2 through 5? They don't exist. Here's a PLC with a web interface, directly connected to the internet. I did not try this, but default usernames and passwords might have worked. I don't know. So this whole thing with Purdue is, it's nice, but it's just a model. All right, let's go to the next slide, please. Sorry, one more. OK. Remember how I mentioned that many of these devices, because of a lack of security governance, they have default usernames and default passwords. These are all easily searchable on Google as well. You don't have to go very far. You don't have to work very hard to get to them. All right, next slide. Now, if in the case, for example, you find a device that actually does have a non-standard username or password, remember what I said earlier about patching. These devices are often never patched. And you can go right to the CISA website and get a catalog of vulnerabilities that you can try out for exploitation. And the next slide. And for those of you who think, well, I don't know much about OT devices, like what tools do I even use to compromise them? Well, Metasploit has modules already there. So, all right, next slide. I hope at this point I have impressed upon everybody here to go and rethink about moving off grid. No, not really. But I hope I impress upon everybody that this is something that we should all be thinking about. If your organization has OT environments, you should really think about what is going on there and what you can be doing to protect it. Earlier, I was a little facetious or cynical when I said, politicians don't want the bad press, or these organizations don't want to get fined. But that in no way discounts the importance of availability of OT environments, right? These OT environments are the ones that produce the pharmaceuticals that we need, the electricity that we need, the gas, and the oil that we need, and so on and so forth. And so it behooves all of us to think more about securing our critical infrastructure and key resources. And arguably, one of the first things that you want to do as a security team with your OT environment is figure out what you have. Historically, when security teams have tried to go figure out what they have with active scanning, it's resulted in catastrophe. Often unreported. Often unreported. But specifically what happened is when people have scanned their OT environments, they would crash their OT devices, causing the very outage that you're hoping to avoid. And so for that reason, conventional wisdom in OT security says you should be doing passive discovery. Well, let's take a look at that. Next slide, please. So when you do passive discovery, typically what you do is you will span from your switches onto a network collector. So you're gathering that information, and then you are taking inventory of the devices that are talking on the network. You can also do taps, and if you have a super flat network, you can do broadcast as well. But by and large, you're going to be spanning. And spanning is actually very easy, right? It's just 3 iOS commands, and already you have a span port set up. Or I should say, it's very easy in a demo by a vendor, and very easy in a POC by a vendor. How many of you work at a place where you only have one switch? Just one switch? Nobody. Nobody works anywhere where there's one switch, right? So let's go to the next slide and see what reality looks like. Fact of the matter is, you're probably going to have interconnected switches, and it's not going to be just simple 3 iOS commands and then you're done. You're probably going to be using one of these protocols to make it all work. And you better pray that all of your switches support that protocol and that version of that protocol, and so on and so forth. Australia, and the EU. But it's going to take some time, just like everything else. Yeah. Yes.
So one thing I think is
Yes.
it was an IT system,
Right.
but they were so and so system. So is there some relatively see this you're in a different world where IT is bridging the gap with OT to come up with an overall solution for both environments?
Yeah. So he's referring to the gap between IT and OT. These are different operational groups that managing those environments. So and it just makes it worse for security, right? Because security already has this gap with IT, and so now you have this gap with OT as well. So like, it's a triad of non-collaborativeness. I don't know if it's getting any better. I definitely had this one project where our solution was to make sure that there was a streamlined workflow between IT and OT. So that we had this situation where IT and IT security was coming in, and they said they're installing a network access control, right? A NAC. And so they wanted to make sure these devices couldn't just get willy-nilly get on the network, right? That anybody could just plug in. And the OT folks are like, no, you're not doing that, because we need to be able to plug in our devices ASAP. Like, let's say this robotic arm goes down, I need to replace it with another one, I'm plugging that in and it better work, right? And so, our solution was to build this workflow for them that allowed OT to be able to update the NAC without giving OT full access to the NAC, right? Because IT didn't want them to have control over the NAC. And so it was just like, it's, in my case, it was a software-based solution that created that workflow that allowed them to work together. But I think there has to be more than that, right? There also has to be like, culture shift, as you mentioned, like people coming together to understand each other and so on and so forth. I don't know if we necessarily solved that problem between IT and security. So, and I think like IT and OT is even further out, unfortunately. So,
Some network teams that don't talk to security
yes.
or AD, they fight over stuff.
Not my switch, not my router, not my problem. Go away. Yeah. All right. Another one? Oh, come on. Oh, yeah. Well, no, go to him.
Do you foresee a time, like, it's quite obvious that there needs to be kind of an elimination of these silos, if we just simplify it to just IT and OT? Do you foresee a time where OT is part of IT?
OT is part of IT. So, yeah, I don't know what's the best way to put this? Like, on the OT side, you have a lot of technicians. Like, the person that came and installed your FiOS, right? And they come in with the device, they plug this in, and they wire it up, and then they make sure like the light is on, and then they leave, right? There's a lot more of that on the OT side. Whereas on the IT side, I think that there's a larger breadth of knowledge that you need in order to be successful.
Yeah, but I'm just thinking about kind of eradicating the silo mindset, so that instead of being two entities, they are one and the same, serving a greater good.
Based on what I see today, I don't see that distinction completely going away. But organizationally, it is possible. But no, I don't see that right now. Not to say it can't happen. All right, he was next. Yes. Yes. Yep. Data diodes. Yeah.
What do you see?
I've not seen as much thought as you've given it so far in your question. Yeah. Okay.
The other way that you're going to do is to install you will not get from the IT. The only way that you can have fully secure is through data diet, but installing another set of IoT devices, which send your data quickly to the cloud, allow you to,
Just like relays.
yeah.
All right, so let's go to the next slide because I'm going to run out of time. All right, so there was a time where you follow these rules. But these days, you all get into Ubers. If you have a Tesla, you might have allowed it to try and drive you. I think most of you have probably bought Bitcoin at some point, at least a little bit. All of you have worked from home by now. And so maybe it's time to consider active discovery in your OT environment alongside of passive discovery. All right, next slide, please. This is me. If you want to connect, happy to connect. Reach out to me. I like making new friends. All right. Thank you. Right. Yeah. I've seen a few. I've seen a few environments that have set up like a simulation or like a lab.
Yeah.
Like it looks like the thing, real thing. So far, it's mostly been with electrical. Yeah. No, like a full like mock utility electrical plant. I've seen that. In the other industries, not as much. I don't know about being advanced. I think it's just like the wherewithal